Okay, so now we will talk about degree of freedom. So what is this degree of freedom? It is basically a concept that how a particle goes and what are the quantities and parameters of which we can observe of any particle, whether it can be you can say the position, the configuration, means these are the independent quantities of any particle of any ideal gas or normal gas. So if talking about the definition, degree of freedom can be defined as that the total number of coordinates or independent quantities that are required to describe completely the position and you can say configuration of the gaseous system. So if we talk about the particles, their quantities like position, if we talk about the position of any x, y, z, whatever the particle may be, the particle's property can be defined as per the position, velocity, momentum, etc., energy also. For example, when a particle moves along a straight line, let us say along x axis, okay, so the position can be specified by its displacement along x axis. So this kind of degree of freedom is one translational degree of freedom. Okay, so let us say another example. If one particle is moving along a plane and its position at any instant can be determined by x and y axis because the plane is along xy axis. So therefore it has two translational degrees of freedom because it has movement along x axis and y axis. Now if it is moving along any space, free space, then it has a degree of freedom of 3. So how does we basically define this degree of freedom in numerical values? For understanding this, let us say only x-axis. So degree of freedom is just 1. Just for example, now xy plane. So degree of freedom is 2 because it can be moving along two different directions and xyz space. So the degree of freedom is 3. So basically degrees of freedom can be given as f is equals to 3n minus k. So what is this n and k? N is the number of particle which are there in the system, and k is the number of independent relation between the particles. So this can be understood that the gases such as monatomic gas, the particle, the n number of particle is 1, for diatomic particles, for triatomic particles, and so on. So each type, let us say for monatomic, for monatomic. So for monatomic gases like helium, neon, etc., F is equals to, since monatomic means number of particles is 1, so N is equals to 1, and K, since K, how can we determine this K? This basically tells you that it is capable of only translatory motion, since these are of only single atoms. So by the formula 3 into 1 minus 0, because K value is 0 now. So degree of freedom here it is 3. Similarly, for let us say diatomic gases such as chlorine, oxygen, nitrogen, what are the criteria? So N is 2 since the particles are 2, and K is 1. So 2 into 3, 3 into 2 minus 1, that is 5. So degree of freedom for this would be 5. Now the condition is that sometimes diatomic gases also have additional features such as vibrational motion also. Initially we were considering to be about kinetic and potential energies. So in this case, if they are having some vibrational energies also, so degrees of freedom will have an additional factor, that is nothing but 7. So that additional factor has the value 2 and can be added in this. Hence the degree of freedom for diatomic gases is 7. And this happens only at high temperatures. This happens only at high temperature, due to which the vibrational motion starts to exist. Now let us talk about some other triatomic gases also. So triatomic gases such as H2O, SO2, CO2, etc., the behavior is basically some kind of different. How can we say? See, if we are talking about 3 atomic particles, so they may be linear, they may be non-linear. So if we consider first for non-linear, so for non-linear triatomic masses such as H2, SO2, these are non-linear. Okay, so what do we observe here? That the molecule has the molecule has 3 degrees of freedom. Why? Because it is translatory motion, and 3 degrees of freedom due to rotational motion about 3 mutually perpendicular axes. Suppose it may rotate along x-axis, y-axis, and z-axis. So for this n is equals to 3, since the number of particles is 3, and k is also 3. So the overall value 6. So for this the freedom degree will be 6. But for linear such as carbon dioxide, carbon disulfide, etc., what do we see? That the atoms are arranged along a straight line only. So the independent relation between them would be only 2. So n value is 3, but k value is 2. We can say 3 into 3 minus 2, that will give you 7. So for linear characteristics or linear atomic molecules, triatomic molecules, the degree of freedom is 7. Now let us talk about law of equipartition of energy. So what is this law of equipartition of energy? Since there are several number of particles, and due to which the energy is considered to be equally divided. So in such case, there has to be some law which defines the distribution of this energy according to the particles in the system. So what does this law define as? That for this law, yeah, according to this law, uh, let us say for any dynamical, why we are saying it as dynamical? Because since the motion of the particle is always going on, so for any dynamical system, but the overall energy is considered to be constant. So dynamical system in thermal equilibrium, it is said that total energy is distributed equally among all the degrees of freedom. Means whatever be the degrees of freedom, whether it is 2, 3, 6, 7, means as per the particles energy, kinetic energy, potential energy, vibrational energy, rotational motion, translation motion, or whatever be the degree of freedom of the particle of the system of the gas, the energy is equally divided between the particles and whatever be the degree of freedom. And the energy associated, what is the energy associated with each molecule per degree of freedom is 1/2 kBT, where this kB is Boltzmann constant and T is the absolute temperature. So Boltzmann and T absolute temperature. So kB is also constant, absolute temperature is also constant, hence the value of energy of the system is always constant. Now let us talk about mean free path. What is this mean free path? As we have discussed this during the motion of the particles within the system of the gas, let us suppose let us say that particles are continuously colliding suppose this is how the collisions is taking place, means the particle is moving in some random direction, but between two collisions the objects, the particles path is free of any kind of force. Means you can say that between two successive collisions the molecule or the particle moves along a straight line with a straight line path with uniform velocity. So this is the velocity between these two collisions may be some, let it be v1. Okay, this would be v2, v3, v4, and you can see the distance is not same anywhere. Sometimes it is smaller, sometimes it is very large, sometimes it is in between. So the velocity acquired by the velocity and with respect to time this this line path is known as free path. So the overall mean of this free path along during the complete motion of the particle of the system is known as mean free path. So mean of free path, so it has a average distance traveled between two successive collisions. Now let us say that there is this be d1, d2, d3, d4, d5, d6, d7, d8, dn, and so on. So all this average distance traveled. So this average distance traveled is equals to d. In some book there is lambda also. Lambda means wavelength, you can see. But for your sake of convenience, we will take it as d. So d1 plus d2 plus and so on, whatever be the number of collisions upon total number of collisions. So this is the value, means the mean free path is given by. So how would you deduce the expression for this? Let us so it is given by d bar is equals to kb t upon under root 2 pi sigma square and p, pressure. So what does this say is that the mean free path depends on Boltzmann constant, absolute temperature, and pressure, and this can be treated as sigma. Sigma is nothing but, let me tell you, this is pressure, this is diameter. molecular diameter. Okay. So on what factors does this mean free path depends? It depends on, it is inversely proportional to mass of gas molecule. Higher the mass, more will be the mean free path. It is inversely proportional to the density. It is inversely proportional to the um, molecular diameter, and it is directly proportional to temperature, absolute temperature, and it is inversely proportional to the pressure of gas. Higher the pressure, lesser will be the mean free path, because more collisions will be there, the number of collisions will be increased. So on these factors this mean free path depends. And here your topic syllabus of this chapter completes.